This is 141. We're going to take a look at function notation. So we're going to create an expression from described steps, and we're going to evaluate functions. We described a function as a special kind of relation, one that each x-coordinate is matched with only one y-coordinate. In this section, we will focus on the process by which the x is matched with the y. Now, the domain of a function is the set of inputs, and the range is the set of outputs. We can think of a function f as a process by which each input x is matched with only one output y. Since the output is completely determined by the input x and the process f, we symbolize the output with function notation. Now, this is that special notation, and we read that as f of x. Now, the of doesn't mean multiplication. You're not multiplying the f times the x. But the idea here is that the y value is going to be dependent on the x that's chosen. And so x is called the independent variable, and the y is called the dependent variable. So this value is going to be the input, and then this entire value, that's going to be the output. Now, we can do things to our function that can affect the input and can affect the output. First example, suppose function g is described by applying the following steps. Add 4 and multiply by 3. Determine g of 5 and then find an expression for g of x. So this is my input. So I'm starting with 5. Now the first step is to add 4 to it, and then take that value and multiply by 3. So 5 plus 4 is 9. 9 times 3, that gives me 27. Now to find the expression for g of x, what's my input? It's x. I'm going to add 4 to it, and then I'm going to take that value and I'm going to multiply by 3. Now if I decide I want to distribute, I can do that, and I'm going to get 3x plus 12. So now we're going to take a look at this whole input-output process. Whenever we see a value inside our function, that's what we're plugging in for x. Now this is new, this is a little different, but I need us to imagine like there's these parentheses around the variable, and you can erase and plug in whatever it is inside those parentheses. So because it says x here, that's why there's an x inside those parentheses. If I have a -1, that means I'm going to put in a -1 into those parentheses. So if I looked at this as -1 parentheses squared plus 3 times parentheses plus 4, negative parentheses squared plus 3 times parentheses plus 4, I'm plugging in -1 into those parentheses. Now from there, you just simplify. -1 squared is 1. 1 times a negative is -1. 3 times -1 is -3. Plus 4, add that together, you get 0. Now in the same concept here, what am I plugging into those parentheses? 2x. So this is 2x squared, 2x times 2x, that gives me 4x squared, and then 2x times 3x, that gives me 6x. Now multiply the negative, and I get that statement. And I could even look at it as x plus 2. So remember, we're looking at this as negative parentheses squared plus 3 times parentheses plus 4. So inside those parentheses, right, negative parentheses squared plus 3 times parentheses plus 4, I'm plugging in x plus 2. Now we need to be careful here. X plus 2 squared does not equal x squared plus 4 squared. You do not sit there and distribute that. That's wrong. It's saying you have 2 x plus 2's. So you need to FOIL or distribute or whatever it is that you've learned on how to do that. But it's saying I have 2 of them. So that's why I wrote it twice. So now we multiply it. X times x, x times 2, 2 times x, 2 times 2. And then the 3 distributes. And so the negative distributes, combine like terms, because the negative 4x and the 3x and the negative 4 and the 10, combine everything together, and we get that statement there. Let's look at another one. So this one is saying if I have parentheses here, I'm plugging in 0 into those parentheses. So f of 0 would be negative 0 squared plus 3 times 0 plus 4. 0 squared is 0, 3 times 0 is 0, and then I have the 4. So f of 0 is 4. Now this is a little different, right? It says 2 times f of x. So remember, f of x, this is the input. This entire thing, that's the output. So this is saying multiply your entire function, all of f of x, the output, the y value. You're multiplying that entire thing by 2. So if we just look at it as pure notation, this is my f of x. I'm going to multiply that by 2. So 2 times, what is my f of x? That's going to be the negative x squared plus 3x plus 4. And then distribute the 2, and so you get negative 2x squared plus 6x plus 8. Now same thing here. This is saying with your y value of 4x, all you're going to do is just add 4 to whatever that is. And so if my function is negative x squared plus 3x plus 4, I'm adding 4 to it. This right here, that's my f of x, and I'm adding 4 to it. So closing today's lesson, what did we learn today? We learned how to evaluate functions and verbally be able to describe a function. How would you describe evaluating? Well, evaluating is going through the input-output process. So if we have f of x, evaluating is plugging in values for x, and it could be like concrete, like a 3 or negative 2. It could be abstract, like 2x or x plus 2 or x plus h. It can be abstract. Or you can actually manipulate the f of x itself by multiplying a number to it or adding a number to it. This does conclude our lesson. If you have any other questions, please leave them in the comments.